Now, section 6.2 is going to be about factoring trinomials. We're going to, trinomial, remember, is three terms. So we're going to factor trinomials, but on this section, we're going to factor trinomials where the leading coefficient is 1. So the first number is technically 1. Right? Remember, when we don't see a number, it's a 1. So for this section, the leading coefficient is 1. So what we're going to do, we're going to do a little x thing. And I'm going to look for two numbers such that when I multiply them is 14, and when I add my numbers is 9. You guys see where I got my 14 and where I got my 9 from. So I want two numbers that multiply equals 14, but when I add them equals 9. One thing I will suggest is think of the number of factors of 14. I'm going to think of 1 times 14. If I add them, doesn't equal to 9, so I move on. What I'm going to do, my first number, it's going to be increasing by 1 each time. Then I think, 2 is a factor of 14. I go 2 times 7. When I add them equals 9. So those are basically my numbers I'm looking for. So matter of fact, with the positive sign included. Now, the factoring of trinomials with the leading coefficient of 1, what I'm going to do, my factors are going to be m plus 2 and m plus 7. That's basically it. Remember chapter 5? Chapter 5, we covered these. We had the m and we did double distributive. If you guys multiply this, if you guys do double distributive, right, distribute the m first, then distribute the 2, combine your like terms, we will get m squared plus 9m plus 14. So we're basically undoing chapter 5. All right, let's take a look at my example 2. I'm looking for two numbers that multiplied equals 20, but when I add my numbers is equal to negative 9. Because they multiply to a positive, they must have the same sign, either both positive or both negative. But because they add up to a negative number, I'm going to say my two numbers are negative. So I'm going to think, all right, 1 times 20, yeah, that doesn't do it. 2 times 10, yeah, that doesn't do it. 3 is not a factor of 20. Then I go 4 times 5, yeah, that one does. So 4 times 5, because multiplied equals 20, added equals negative 9. So my factors are going to be x minus 4, x minus 5. One thing I want to emphasize here, though, here the exponent of my leading coefficient, it's always half of that. So to begin with was x squared, x to the 1. So let's say I had x to the 10 to begin with. My exponent was x to the 10th. My leading my exponent here will be x to the 5th. Right? It's always half of that. All right. So we're good. My factors are x minus 4, x minus 5. Now, let's take a look at another example. This one has letters. Ignore the letters for a moment. I'm looking for two numbers that multiplied equals negative 3, but when I add them equals negative 2. Because they multiplied to a negative, I know the signs are different. So in this case, I remembered back in chapter 1, we said that when the signs are different, we subtract the values. So now I'm looking for two numbers that multiply equals 3, negative 3, but when I subtract them equals 2. All right, so let me call this negative 3 and 1. All right, so these numbers, when I multiply, will equal negative 3. When I add them equals negative 2. I said subtract, because remember, when the signs are different, we subtract the values. So 3 minus 1 gives us 2. And obviously, we keep the sign of the large number. Now here, I'm going to go see my c squared. I'm going to start with c plus 1. But in this case, I'm going to add a b. C plus 1b. And the reason why, because the ending has a letter. It has a b squared. Once again, I'm going to go with half of it. My other exponent is going to be z minus 3b. I know in the centered, we have bz combined, but pretty sure when I distribute the z with the negative 3b, that's where I get the bc combined. Remember what we used to do in chapter 5. So when we have two letters, we're going to have both letters inside the parentheses, kind of like we see here. Now, my first term, my first parenthesis, z plus 1b, if you guys just write z plus b, because that represents 1b, that's also correct. Mathematically, they're both correct. and then obviously z minus 3b. So mathematically speaking, these two are correct. We try to ignore the one, but if you guys write it's fine. All right, let's take a look at this other one. I said that the leading coefficient to begin with was going to be 1. So my first number was going to be 1. If it's not 1, well, there must be a greatest common factor, at least on this section. So I'm looking at my factors here, my numbers here. Let me divide everything by 4. Numbers-wise, I can divide everything by 4. Letter-wise, I can factor out an x to the third. So open parentheses, because remember I'm going to factor out, so I'm going to undo the distributive property. Let me divide everything by 4x to the third. So I have x squared minus 7x plus 10. Now I'm just focused on the parentheses. I'm looking for two numbers that multiply equals 10, but when I add them equals negative 7. So I'm going to think of negative 2, negative 5. So my parentheses by itself, it distributes to x minus 2 and x minus 5. That's how we factor out the parentheses. But on the answered, don't forget your 4x cubed, because that is your greatest common factor. When we say factor out, we basically factor everything. So this will be my answer. 4x to the third times x minus 2 times x minus 5. So don't forget the greatest common factor to begin with.